we are given a sequence in each part, and we are asked to find a closed form for the generating function of each sequence. So the first sequence we're given is 0, 2, 2, 2, 2, 2, 2, 0, 0, and so on to infinity. The generating function for this sequence is g of x equals 2x plus 2x squared plus 2x cubed plus 2x to the fourth plus 2x to the fifth plus 2x to the sixth. And to write this in a closed form, factor out a 2x. So this is 2x times 1 plus x squared plus x cubed plus x to the fourth plus x to the fifth. And by a previous theorem, we have that this is equal to 2x times x to the sixth minus 1 over x minus 1. And this is our answer for part A. In part B, the sequence we're given is 0, 0, 0, 1, 1, 1, 1, and so on. The generating function for this sequence, g of x, is x cubed plus x to the fourth plus x to the fifth, and so on. This is equal to, if you factor out x cubed, 1 plus x squared, and so on. And this is equal to, by a theorem, x cubed times 1 over 1 minus x. And this can be abbreviated as x cubed over 1 minus x. In part C, we're given the sequence 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, and so on. And we have the generating series for this sequence is g of x, which is x plus x to the fourth plus x to the seventh plus x to the 10th, and so on. And if we factor out x, this is x times 1 plus x cubed plus x to the third power squared plus x to the third power cubed, and so on. And we have, by a theorem, this is equal to x times 1 over 1 minus x cubed, or x over 1 minus x cubed. In part D, we are given the sequence 2, 4, 8, 16, 32, and so on. And so we have that the rule here is a sub k is going to be 2 to the k plus 1, where k is equal to 0, 1, and so on. And we have that the generating function for this sequence, if we say g of x is equal to the sum from k equals 0 to infinity of ak x to the k, then this is going to be equal to the sum from k equals 0 to infinity of 2 to the k plus 1 x to the k, and this is equal to, factoring out a 2 times the sum from k equals 0 to infinity of 2x to the k, and we have that this is equal to, by a theorem, 2 times 1 over 1 minus 2x, which is equal to 2 over 2, or 1 minus 2x. In part E, we are given the sequence 7 choose 0, 7 choose 1, up to 7 choose 7, and then 0, and so on. The generating function for this sequence is going to be g of x is equal to 7 choose 0 plus 7 choose 1x plus up to 7 choose 7, and this is x to the 7th. We have that this is equal to 7 choose 0 times, and this is 1 to the 7th times x to the 0 plus 7 choose 1 times 1 to the 6th times x plus up to 7 choose 7 times 1 to the 0 times x to the 7th. We recognize this is the same as the sum from k equals 0 to 7 of 7 choose k times 1 to the 7 minus k times x to the k, which from the binomial theorem, this is the same as 1 plus x to the 7th. In part F, we are given the sequence 2, negative 2, 2, negative 2, 2, negative 2, and so on. And so we have that this sequence follows the rule that, well, before we do this, we have that the generating function g of x is equal to 2 minus 2x plus 2x squared minus 2x cubed plus, and so on. If we factor out a 2, we have 2 times 1 minus x plus x squared minus x cubed, and so on. We have that this is the same as 2 times 1 plus negative x plus negative x squared plus negative x cubed, and so on. And this is equal to, by a theorem, 2 times 1 over 1 minus negative x, which is equal to 2 over 1 plus x. In part G, we're given the sequence 1, 1, 0, 1, 1, 1, 1, 1, 1, and so on. So recognize that the generating function for this sequence, g of x, is equal to 1 plus x cubed plus x to the fourth, and so on. This is equal to 1 plus x squared plus x cubed, and so on, minus x squared. And by a theorem, we have that this first part is going to be equal to 1 over 1 minus x squared. In part H, we're given the sequence 0, 0, 0, 1, 2, 3, 4, and so on. The generating sequence for this function is x cubed plus 2x to the fourth plus 3x to the fifth, and so on. And if we factor out x cubed, this is equal to x cubed times 1 plus 2x plus 3x and 3x squared, and so on. And recall that from the table, we have that this sum is equal to x cubed times 1 over 1 minus x squared and so this is equal to x cubed over 1 minus x squared.